Hi friends, my name is Bhavya Mangla. I'm IATF qualified auditor doing audit for the automotive sector for the last 18 years. I'm again back with a very interesting topic, and that is related to problem solving technique. It's a series going on of 7 different steps. So today I'm going to talk about incomplete from step number 1 to step number 7 by using an example that how we can use the problem solving technique. Well, if we talk about the problems, then generally we pray to the God that let there be no problem. But we know that problems are part and parcel of life. What we can actually do is we can pray to the God that they give us a strength that we can face all the problems. Now, the problems can be in our routine life or maybe in the professional life. So, in the professional life, there are different techniques that are being used for resolving the problem. 8D is one of the very popular technique which was initiated by Ford. So in this particular video, I'm going to talk about 7 different steps. By using that, we can resolve a problem, and we'll do it by taking an example. So when we talk about the 7 steps, the first step is talking about defining the problem. The second step is about containment, correction, and the interim action. Step number 3 is talking about the root cause analysis, where I'm going to talk about 2 different steps. One is about the 3Y, 5Y and 3 lag analysis, and the second is about Ishikawa diagram. Then the fourth step is with respect to the corrective action. The fifth step is talking with respect to the effectiveness of the corrective action, that we have to verify that whether the corrective actions are effectively implemented or not. Then step number 6 is talking about horizontal deployment, or in Japanese terminology it is also called yokoten. And the last and the 7th step is talking about whatever the documentation, lesson learned, and how we are making the people aware about what all actions we have taken. So let's start with step number 1, that how to define the problem effectively. So let's assume that we are taking an example of a company, maybe a tier 1 company, who have received a customer complaint, and that is about the molded component which was supplied to an OEM, and maybe say for example 100 pieces got rejected because of the fitment problem. So what can be done with respect to that? So when we talk about step number 1 about defining the problem, so here the most important thing that coming out here is that how we can make the problem as accurate as possible by using a cross-functional team approach. Well, Robert Humphrey has very rightly said that an unidentified problem has an infinite number of solutions. So the more accurate and focused our definition is, the closer we are going to be the solution. So I'm going to talk with respect to a Kipling method, which was named after Rudyard Kipling poem, I Keep 6 Honest Serving Men. So the first question is, what exactly is a problem? So in that we can talk about what exactly is a defect, what about the part number, maybe the drawing number, any model which is there with respect to that problem, what about the quantity. Then why is the problem important? Is it because it is a repeated problem, or maybe because it is related to some safety critical characteristic, or maybe it's a routine problem which has just happened. Then the third question can be, when did the problem arise and when does it needs to be resolved? So we can know about the date, about the shift, first shift, second shift, third shift, and what was the completion date target which has been given by the customer. The next is, how did the problem happen? Is it related to visual, fitment, function? Which was the operator which resulted in this problem? Which was the inspector name who identified the problem? Then the fifth question is, where is the problem occurring? Is it occurring at the customer end? Then which customer? Then which location? Maybe a customer has got different multiple locations. So from which location this problem is affected? And the last, a very important question, who does the problem affect? Is it affecting the end user who is going to use the particular product, or maybe the next process inside the organization, or it can be the final assembly inside the organization? Is it impacting any legal requirement, or maybe any other stakeholder? All these can be the possible questions that can be asked. That brings step number 2, where we will talk about correction, containment, and the interim action. Well, whenever any problem is happening, 5 possible actions are there. Either we are segregating the material, or we are reworking it. Third is repair. The fourth one is we can taking a deviation or concession from the customer. And the fifth and the last is that we are scrapping that particular product if we are not finding any solution to that. Now we talk first step with respect to the correction. When we talk about correction, the basic intent is to eliminate a detected non-conformity, but not a corrective action in detail. We are just correcting that particular non-conformity so that we can take care with respect to that. So let's take an example. Like if you remember, we are talking about a molding process wherein the material has been rejected because of the fitment issue. Now we identified that it is coming out because of the flash in the molded component. Now what we can do? We can simply add a deflashing process immediately after the molding process, so that the flash should not go to the customer, because at this moment we are not very sure about the root cause, but this action will at least take care with respect to the problem. Now the second step here is about the containment. That problem has happened. What to do? Because there can be a possibility that the problem can be at different stages. It can be at the supplier end, it can be maybe at the organization end, maybe in the transit, maybe at the customer end, or maybe somewhere in the go down or somewhere. So we need to identify that which are the different places where the material could be, and we need to contain that. Let's take an example with respect to the same of the molded components. So we can identify the different stages, maybe the material kept at the dispatch stage, maybe the material at the customer or supplier end, in the transit, and all the other locations where we can stop the material from further usage. That brings third point in the step number 2 about the interim action. Now interim actions are primarily also called the first aid actions that protects the customer from the problem until we identify the root cause analysis. So again, it's primarily a response that is taken in emergency, which is done with some minimal supporting documents. So again, taking an example of the molding process where the flash is coming in the molded component. So what we can do, maybe the process engineer can review the process parameter and can look into the temperature, time, pressure, and can make some minor modification here and there with some trial so that the flash can be controlled. And till that time a detailed root cause analysis is found out, some action can be taken. So that is a part of interim action. That brings step number 3 about the root cause analysis. Well, Mr. Deming has said that 85% of the reasons for failure to meet the customer expectations are related to the deficiencies in the system and processes rather than the employee. So here the most important thing is that whatever root cause that we are going to identify, it should be with respect to a process and not with respect to a person. So here I'm going to talk about 2 different steps or 2 different ways of doing the root cause analysis. The first one is 3-layered 5-why analysis, and the second one is Ishikawa diagram, or it is also called a Fishbone diagram. When we talk about 3-layered 5-why analysis, here the main intent is that rather than looking into the symptom of the problem that we can see above the surface, we need to look into the underlying causes, the root cause, which is below the surface, which is not obvious. And when we talk about 3-legged, we are talking about 3 different things. One is about the occurrence, that why the problem has actually occurred. We need to do the why analysis with respect to that. Then the second step is about detection, that okay, the problem has happened, but why it was not detected and why it has gone to the customer. And the third one is about systemic lag, that okay, the problem has happened, but what was the failure with respect to the system which has resulted in this particular failure. So this is about the 3-leg 5-why analysis. Now that brings a very interesting question, that for how many times we should ask why. So first of all, one simple logic is that we need to ask why till the root cause is uncovered. But in general, it is being observed that when we ask 5 whys broadly, during that time we can identify the actual root cause. Because if you are not asking the enough whys, there is a possibility that we may end up with respect to the symptom and not the root cause. So a root cause is generally a process, maybe a policy, it can be a design or a person. And there can always be more than one root cause. So let's take an example of a very basic, simple root cause analysis, wherein we are taking an example of a vehicle which is not starting. So what can be the possible 5 whys in which we can do that? So the first why which is coming out is that the battery is dead. That's why the vehicle is not starting. Fine. But what is the second why? It is the alternator is not functioning properly. That is the reason. The third is that why the alternator is not working. Maybe the belt has broken. That is the reason that alternator is not functioning. But why the belt has broken? Maybe because it is well beyond its useful service life and it is not replaced on time. But why it had happened? So maybe one of the very popular and routine root causes is that maybe the vehicle is not maintained according to the recommended service schedule. So this is a very simple example about 5 why which we can use it. But considering the 3-leg 5 why, we need to ask 5 whys with respect to the reason why the problem has occurred, Then second, why the problem was not detected when it happened. And thirdly, with respect to the systematic root cause. Now to talk about the second root cause analysis technique. So another easy way is to use an Ishikawa diagram, which is also called a fishbone diagram. So in 1960s, Karu Ishikawa identified this particular technique wherein for multiple root causes for one quality issue, it can be utilized. So if you see in this, it is primarily in the shape of a fish when we talk about the different causes. That's why it is called a fishbone diagram. One very important thing is that there can be multiple causes. First can be the primary cause and second can be the secondary cause which is related to the primary cause. So we need to identify both the causes. So let's take an example wherein we are talking about that maybe a problem is there with respect to the product quality which is not meeting the quality standard. So we identify different possible causes. It can be related to the worker, which is men, then raw material, then it can be third machine, and it can be the other miscellaneous problems. Then by using a fishbone diagram, we can identify all the different possible causes which are there, which are possible, which is resulting in this particular problem. And by identifying that, we can identify all the possible reasons, primary causes and the secondary causes. And once we identify that, after that, we can see that which are the actual reason which is possible. And once we identify that, then we can take the necessary action on that and go ahead with the proper corrective action. That brings step number 4, that is talking about the corrective action. So when we talk about the corrective action, the main intent is to prevent the recurrence of the problem, to streamline the workflow in which the things can happen, to identify the cost-effective routes to correct the error, and to eliminate the deficient practices. And it is very important that whatever corrective action that we are proposing, it should be related to the non-conformity that is being encountered. So when we talk about root cause analysis and related to the corrective action plan, so let's assume that one example with respect to occurrence. If you remember in the previous case, we were talking about 3 leg 5 analysis. So the first leg was with respect to the occurrence. And in that occurrence, assuming in that particular example, the final root cause that we identified is with respect to the various leaks, high demand at full plant capacity, and the bleeder hole plugs that cause the pressure drop. So what can be the possible corrective actions here? So in this example, it can be, first of all, we need to reset the machine setting and disable the machine whenever the pressure is dropping. That can be one of the things that can happen. Secondly, we can verify the pressure from time to time on a sampling basis in the beginning of the shift, in middle and in the end. And we can regularly monitor the pressure maybe for the next 30 days. That can be one of the possible corrective action. Now talking about the second leg, that is about the detection. And assume that we identify the final root cause, that is talking is with respect to the process capability study, that there are different special causes that is appearing which is resulting in that problem. So what can be the possible corrective actions that can be there? So the one of the possible corrective action can be that we can do 100% sorting for the material which is already being made. The second can be that we can create a log sheet wherein we can regularly do the inspection to see that why the problem is coming, and so that we can monitor all the actions with respect to that. We can redesign the chamfer gauge so that we can check it from time to time. Maybe the inspection frequency can be increased from 2 hours, maybe from 4 hours to 2 hours per shift. A machine capability study can be done with respect to the thread gauge or with respect to the chamfer dia, and there can be other possible results. Talking about the third, which is about the systemic failure, that why it has happened, and assuming that the root cause which has been identified is primarily with respect to the APQP process and the severity level which has not been identified effectively. So maybe in this case, the possible corrective action can be related to the design records and the FMEA which needs to be reviewed and updated from time to time, and based on that, maybe the control plan needs to review, and maybe we can think about 100% inspection for the key parameters, or we can also think about the layered process audit to standardize the process to verify that whether the process is working as per the requirement or not. These can be some of the possible things. That means step number 5, which is talking about the effectiveness evaluation, that we have taken the corrective action, but whether all those corrective actions are effective or not, that we need to check here. And there can be different steps that we can use. So here I'm going to talk about 13 different steps that we can use to identify that how we can identify. So first, the very simple and the basic thing is that whether the action plans are actually implemented or it is just on paper. Then second could be that yes, we did identify the corrective actions, but actually whether they are practical to implement or it is difficult to implement all that, whether we have communicated to all the relevant stakeholders about the actions, or maybe it is still in the computer and nobody knows that what are the actions which has been implemented or which has been planned to implement. Then by implementing that, what are the timelines that we have identified, that which date which action needs to be implemented, whether it has been done as per the requirement or not. Then what about the material which was in question, which was under rejected? Whatever actions that we identified with respect to that rejected material or the material in question, what we have done with respect to that. Then there may be so many documents that need to be reviewed and updated, whether it has been done or not. What about the validation? Whether it has been done to verify that whatever proposed actions are there, they are actually working and it is going to serve the purpose. Then in case there is any identification or traceability requirement which is there, whether it is actually implemented or it is still on paper. Then have you taken any feedback from the customer? Because unless and until we get the feedback from the customer that whether customer is satisfied with whatever actions we have taken, it will not serve any purpose that what we have done over that. Then the next important thing is about the effectiveness part, that we have taken an action, but over a period of time, maybe 3 months or 6 months, are we verifying? Do we have a structured method to see that whether the effectiveness is verified or not? Then do we have any internal process like internal audit? It can be of different type like system audit, product audit, manufacturing process audit, to verify that the whatever actions that we have taken, it is in place. And lastly, the 13th and the most important step, what about the involvement of the top management? Whether management is aware about it, that the problem has come and actions have been taken, any if action has been taken, what is the present status with respect to that? So these all are the possible things that we need to ask with respect to the effectiveness monitoring with respect to the corrective action plan. That brings step number 6, which is with respect to the horizontal deployment, or in Japanese terminology, it is also called as yokoten. So we have taken the action, which is fine, but there can be different other processes also where similar kind of problem can appear again. So what we are doing with respect to that? And when we talk about horizontal deployment, it is not only about the positive thing, it can also be with respect to the failures also that we observed. So we need to do that horizontally wherever it is possible. So let's take an example again with respect to the systemic failure, that we did the systematic analysis and based on that we identified some actions. Now whatever actions that we have taken, whether the same thing can be repeated in other process. Say for example, one of the systemic failure is with respect to the dust, that problem has appeared. Now dust has resulted in the problem in one of the product failure, but there are other electronic components, say for example an electronic product. It can be semiconductor, resistor, capacitor. Have we deployed the horizontal actions with respect to the other things also or not? Now similarly with respect to the man, we did identify that there was a competence issue and we provided the on-job training for one of the process, and this process is with respect to the QR code wrongly pasted. Now the QR code is pasted in some other assembly line also. So have you trained the other people in the other assembly line also with respect to how to paste the QR code correctly? Similarly with respect to the machine, in case we identified fixture as a problem and we corrected the fixture, but what about the other machines which have got the similar kind of product and the similar kind of issues can come here? Say for example the PP molding, whether the cooling feature is given for the other machines also or not. And something similar can be done with respect to the material and the method also, wherein we may be implementing some actions at one place, but what about the actions on the other places? Then brings the last point, the 7th step, where we are talking about the documentation, lesson learned, and promotion of awareness. Now, whatever actions that we have taken from step number 1 to step number 6, they will not be sustainable unless and until we have an effective system of documentation. And if we talk about an organization, there are so many documents that need to be reviewed and updated, starting from step number 1 to step number 6. And all those documents, if I give some example, it can be related to drawings, process flow diagram, FMEA, control plan, standard operating procedure, 1-point lesson, skill matrix, machine history card, supplier PPAP, procedures, internal audit, management review output, and there can be so many things which can be a part of that. And once the documentation is completed, it is also important that what are the lessons that we have learned with respect to the whatever actions that we have taken. Is it just related to that particular problem, or we have incorporated all those actions in other processes also? So once we do that and we give the awareness to all those people, then we can, yes, really say that whatever actions that have been taken, they are effective. To talk about some of the industry challenges with respect to the problem solving technique, first and the very basic thing is that how often the people who are working in the organization, they are aware about the systematic problem solving technique. Secondly, how often it is happening that whatever actions are being taken, they are actually being done by using a cross-functional team approach and not one person doing that. And thirdly, and the most important, whatever is a cross-functional team that is working on the problem-solving technique, whether they're actually competent in using the problem-solving technique or not, maybe subscribed by the customer or maybe organization's internal system is there. These are some of the key questions that we need to ask to ourselves. So if I do a summary, I talked about the 7 problem-solving technique, starting first from how to define the problem, then about correction, containment, and the interim action. Then I talked about the root cause analysis, where I talked about 2 different techniques, about 3-leg 5-why and the Ishikawa diagram. Later on, I talked about the corrective action implementation. Then the next step was about the effectiveness of the corrective action implementation. The step number 6, that was with respect to the horizontal deployment. And the last step was with respect to the documentation, lesson learned, and how we can promote the awareness about the actions taken inside the organization. Well, my next topic is talking with respect to the causal factors whenever we are analyzing any problem. Regularly, I'm getting a lot of feedback from your side and they're helping me to understand your expectations. So please do continue that. And in case you want to understand about this particular video little bit in more detail, so you find a link below. If you click that, you'll find a blog there, and there you'll find this information in much more detail. And in case you're liking these kind of videos and blogs, you can always share with your friends and colleagues, and you can subscribe to my YouTube channel and my website bhavyamangla.com. Thank you.